Hi everyone, this is Emery again, and tonight we are going to talk about an interesting topic, the case of two related samples, McNemar test for the significance of changes. So, without further ado, let's proceed. Who wants to read the first slide, everyone? Okay, go on, Jeanette.
A non-parametric test that is used to compare two population proportions that are related or correlated to each other. It is used when analyzing a study where subjects are assessed before and after the study.
Okay, thank you very much, Jeanette. It was defined in the slide that McNemar test is a non-parametric test. So when we say non-parametric, it means that it does not require complicated assumptions like the normal distribution. So in McNemar test, it compares two related proportions. So when we say kanang related, this means that the same participants are measured twice or the participants are paired. For example, researchers wants to know if students improve after review classes, so they test students before the review and after the review. Because the same students are measured two times, McNemar test can be used. So why it's appropriate? It's appropriate because the subjects or respondents are accessed before and after the study with their implementation or actions. Have you understood, everyone? Am I understood? Okay, I think silence means yes. So let's proceed to the next slide. Okay. So now we are here sa assumptions of McNemar's test simplified version. So who wants to read the slide? Anyone? Okay, Jezebel, you go read the slide.
Assumption number one, the study must have one dichotomous dependent variable or only two categories and two related groups or paired measurements.
Thank you, Jezebel, for reading. Now let's proceed. So, the first assumption of the McNemar test states that the variable must be dichotomous. So, when we say dichotomous, it means that there are only two possible answers. So, what are these two possible answers? So, let's proceed to the next slide. So here are the examples of the dichotomous variables. So we have pass or fail, yes or no, safe or unsafe, smoker or non-smoker. So the same participants are usually measured twice, such as before and after an intervention. These are examples of dichotomous variables because each participant can only belong to one category. For example, a student cannot be both pass and fail at the same time. This is important because McNemar test only works with two categories. So, gets everyone? Okay, let's proceed to the next assumption. Okay, who wants to read the second assumption? Anyone from the group? Okay, go, Michelle.
Assumptions of McNemar's test simplified version. Assumption number two, the two categories must be mutually exclusive. This means a participant can belong to only one category at a time.
Thank you for that, Michelle. So, in assumption number two, it is highlighted here the word mutually exclusive. So, this means a participant can belong to only one category at a time. So, dili siya pwede nga kanang nakapasar ka while at the same time nahagbong because there's no such thing nga inana. So, if if pasar ra jud ka, dili ka pwede mahagbong. 'Di ba? Nagets ninyo ang logic? Okay, let's proceed to the example. So, example, in an exam, a student can either pass or fail but cannot do both at the same time. So, muna akong gingon nga diha nga dili siya pwede no nga doble iyahang entry. So, now let's proceed to the assumption number 3. Who wants to read this slide? Ako day. Okay, go Kevin. Assumption number 3. The participants should ideally be a random sample from the population. McNemar's test is commonly used when the same participants are tested twice and the answers are classified into only two categories. So, in assumption number 3, it is highlighted here the word random sample. So, this means that the third assumption is random sampling. This means participants should be selected fairly so the study becomes reliable. Also, remember, McNemar test is commonly used when the same participants are measured 2 times. So, gets everyone? Okay, gets. So let's proceed for the example. So researchers check whether smokers change into non-smokers after watching an anti-smoking video. Since the same people were measured before and after, McNemar test is appropriate. So, nga naman, since you wanted to know if there are changes of smokers after watching an anti-smoking video, you check the same people before watching the video and after watching the video. So, in this example, participants were measured twice and the answers are only smoker or non-smoker. So, McNemar test is appropriate. Now, let's proceed to the next slide. So, who wants to read the whole contents of this slide? Anybody from the group? Ako, te Mars. Okay, go die, Jeanette. Requirements of McNemar's test simplified version. First, random sampling. The participants or sample data should be randomly selected from the population. 2. Matched or paired data. The data must come from the same participants measured twice or from matched pairs. Example, scores of students before and after a review session. 3. Nominal data with 2 categories. The data should be classified into categories with only 2 possible answers. Examples, yes or no, pass or fail, smoker or non-smoker. Each observation is grouped according to the match pair and according to one of the 2 categories. Okay, thank you, Jeanette. So, as you notice na ang requirements of McNemar's test kay same-same ra siya sa ihang assumption in which it requires random sampling, so, and then match data or pair data, and then nominal data with 2 categories only. So, same-same ra sila no, so, understandable ra kayo. So, if nasabtan ninyo dito ang sa assumption sa McNemar's test, dali na lang po diri sa requirements sa McNemar's test. So, I think I don't need to explain anymore sa iyang requirements since na-explain na sad ni sa ato ang previous slides. So, let's proceed to the next slide already para dili ta maka-cause of too much delay. So, in this table, we will get to understand better how was the McNemar's test formula was formulated. So, the data in McNemar test is arranged in a 2 by 2 table. So, the letters A, B, C, and D represents frequencies or number of participants, and the most important values are B and C because they represent changes. So, let's proceed to the next slide lang kay we will dig deeper or explain further kung anong naunsa na siya pag-derive and what so on. Okay ra ba everyone? Okay? Okay, silence means yes. So, let's proceed to the next slide. So, in this slide, it is kanang elaborate na siya no, explain better. So, nganong ang A and D nga equation or letters kay gi-cancel. It's because kanang stagnant ra sila. So, if before and after the video kay ni okay sila, so wala tay makita nga changes no. So munang ang A ug D kay kanang cancel siya sa equation. Nababantayan sa nato nga ang equation sa or formula sa McNemar's test kay square is equals to B minus C raised to the power of 2 over B plus C. No? So, para masabtan, I will give an example. So, kanang a participant who answered yes before and yes after did not change. So, wala tayong makitang changes. So, cancel siya, i-ignore siya. And then, a participant who answered no before and no after also did not change. So, ato siyang i-ignore kay there is no changes nga itong nakita. But, a participant who answered yes before and no after kay there is a change. So mo na siya nga ato siyang i-appeal. Kay na may changes nga nakita. So nagets ninyo nga nung na-cancel si A o si D nga ang B o C kay nagpabilin? Nasabtan na no kay it's because A and D provide zero information about whether a change occurred. So, di ba? Gets na ko everyone? Okay, so gets naman ko. Let's proceed to the next slide which is the McNemar test formula. So, mauna ni ang formula sa McNemar test. Chi-square is equals to B minus C raised to the power of 2 over B plus C, wherein X squared is the chi-square test and then B is the first cell of the second column in a 2 by 2 table and C is the first cell of the second row in a 2 by 2 table. And then chi-square statistics is with 1 degree of freedom. Okay, let's proceed to the next slide, which is the hypothesis. And in here, we have the null hypothesis. So it states that there is no significant change. So this means that the intervention or treatment had no effect at all. So example, the number of students who improve is almost equal to the number who became worse. So let's proceed to the next slide, which is the alternative hypothesis. So in alternative hypothesis, there is a significant difference or change. So, the alternative hypothesis states that there is a significant change, meaning treatment or intervention had an effect at all. So, example, more students improve after the review class. So, next. Okay, significance testing. Who wants to read the contents of this slide? Anyone from the group for participation? Sige, panguan na mo. Tubag. Paningog na mo. Anyone? Wala. Kay mang call out ko og classmate nga pa basahon. Ako, day. Okay, go, Kevin. Significance testing. In McNemar's test, significance is tested by the chi-square table. So McNemar's test calculated value is compared with the chi-square table value. If the calculated value for McNemar's test value is greater than the table value, reject the null hypothesis. And if the calculated value is less than the table value, accept the null hypothesis. Okay, thank you, Kevin. So, I think understandable ra siya no, kay same ramang din siya og concept or process sa ubang statistical test. So, kanang you only need to compare the computed value and the table value. So, if the computed value is greater then reject null hypothesis. So, after solving the formula, we compare the computed value with the tabular or critical value. So, we only have to remember something. If computed value is greater than the table value, reject the null hypothesis. So if computed value is lower, then accept the null hypothesis. So usually the table value used at 0.05 significance level with 1 degree of freedom is 3.841. So para mas masabtan, let's proceed to the next slide and we'll have the example. Okay, so example 1. Data on seatbelt used before and after involvement of car accidents for a sample of 100 car accident victims. So, in this example, researchers wanted to know if people became more likely to wear seatbelts after experiencing a car accident. So, the same people were checked before the accident and after the accident. So, if you will have the data, then you will just encode or input here sa given na table. So ato makita sa table nga naay ni yes nga 60 ka buok before and after the accident, while nasay ni no before, then a yes after nga 19 ka buok, and then yes before and no after nga 6, and then no before and no after nga 15. So if amo ito na siyang i-total na mukuha na into 100 sample. So Gets ra giunsa ni siya pagkuha ang kaugi ko giunsa na unsa ni ang table. So if gets ra, let's proceed to the next slide. Okay. So here we have the problem. Is there a significant difference if seatbelt before and after involvement in the accident? So atong null hypothesis, there is no significant difference in the use of seatbelt before and after involvement in a car accident, and then atong alternative kay there is a significant difference in the use of seatbelt before and after involvement in a car accident. So after nato ma-state ang hypothesis, let's proceed to solving. So example 1, so gikuha sa nato ang level of significance. So atong alpha kay kanang 0.05. So ang kaning degrees of freedom constant jud ni siya nga 1 kay kanang mao man jud na siya. So ang ato ang chi-square kay 3.841. So ako na ning gi-state sa another slide nga always jud siya nga 3.841 if atong alpha kay 0.05, since ang atong degrees of freedom kay is always 1 man siya. So tanaw nato sa iyang critical values, di ba? Sa degrees of freedom 1 and then 0.05 yung value kay 3.841 jud siya, no? So mao na siya. Okay, nakuha naman nato ang level of significance. Let's proceed to the next slide. So, ari na ta sa computation. So, using the McNemar's test for correlated proportion. So, ang formula, kung sa ito ang formula, chi-square is equals to b minus c raised to the power of 2 over b plus c. So, you only have to substitute the given values or datas nga atong na-accumulate. So, ang b is equals to 6 and then c is equals to 19. So, if you were going to compute this one, you will get chi-square is equals to 6.76. So, the conclusion is here. Since the computed chi-square is 6.76 larger than the tabular value of 3.841 at 0.05 level of significance with 1 degree of freedom, the null hypothesis is rejected in favor of the research hypothesis. So it implies that there is increase in seatbelt use after involvement in a car accident. Kay ato ang chi-square nga 6.76 is greater than 3.841 man. So therefore reject the null hypothesis. So there is a significant difference in the use of seatbelt before and after involvement in a car accident. So nasabtan na everyone. So if dili masabtan kay ibalik lang ang kaninga video or continue because we will rather I will give another example. So this is the last example nga I prepared. So please listen carefully, no. Kay last example na ni siya sa McNemar's test. Okay? So here is the example 2, comparing treatments. 2 different creams are used to tinea pedis or athlete's foot. Each subject with this fungal infection on both feet is given treatment of pedia cream on one foot while the other foot is treated with fungi cream. So the researchers wanted to know if one treatment worked better. So okay, let's proceed to the next slide. So using a 0.05 significance level, apply McNemar's test to test the null hypothesis that the following proportions are the same. So the proportions of the subjects with no cure on the pedia cream treated foot and a cure on the fungi cream treated foot. The proportions of the subjects with a cure on the pedia cream treated foot and no cure on the fungi cream treated foot. Okay, let's proceed to the next slide again para mas masabtan siya dug ayo. Okay, so here is the table. Okay, so given na ang data daan ha. So 80 subjects on 160 feet. So 12 had both feet cured and then 20 had neither foot cured. 8 had no cures with fungi cream but not pedia cream, and then 40 had cures with pedia cream but not fungi cream. So based on the results, thus there appears to be a difference between the two treatments. Thus one of the treatments is better than the other. So let's try to find out in the next slide. So okay, just same sa example 1, kanang we need to get the level of significance first and then kanang the critical value. So iyang alpha kay 0.05 degrees of freedom is always 1 and then makuha ra siya no. Mao ra to nga 3.8481. Sakto ba? And then i-compute nimo, substitute the given values gamit ang formula sa McNemar's test and then you will get the chi-square value which is 21.333. So, conclusion, with a 0.05 significance level and degrees of freedom by 1, the test statistics of chi-square equals 21.333 exceeds the critical value of chi-square which is 3.841. So, reject the null hypothesis. It appears that the two creams produce different results. Analyzing the frequencies of 8 and 40, more feet were cured with pedicream than fungi cream. Nakuha ra ninyo everyone? Like, did you understand giunsa pagkuha siya? Namoy mga clarifications or questions? Kay kanang akong tubagon. Okay, I think wala ra no. So, thank you everyone for listening and for being here sa akong online reporting. So, kanang pwede na mo left sa kaninga Google Class. Thank you. Ay, last announcement di ay everyone before you left this kanang class. Kanang ang attendance and assignment kay I will just send it to the GC hanya kanang naramasad ko'y copy kinsay nakasulod and then sa mga ni-excuse kay na ay ipang-attendan. Okay, that would be all everyone. Thank you so much. Salamat yun sa pagsulod. Bye-bye everyone. I hope you learned something from today's discussion. This is Emery once again, signing off as your reporter. Thank you.